Imagine spending $13.3 billion on the most classified warship in human history, only to realize it can't even load bombs onto its own fighter jets. This isn't fiction. This is the USS Gerald R. a historic engineering disaster that crippled U.S. naval superiority for years, and who capitalized on this technical embarrassment. China. While America was trapped fixing its over-engineered carrier, China quietly prepared to launch its Type 003 Fujian, adopting the exact technology the U.S. had spent billions of dollars and years struggling to test. Today, we uncover the massive blunder driven by U.S. Navy engineering hubris, and how China's Fujian is now directly challenging American maritime dominance. The core issue with the Ford wasn't a flawed basic structure. It was the Pentagon gambling on a highly risky strategy, concurrent development. They started welding the ship's hull before the extreme technologies destined for its interior had even survived laboratory testing. Instead of upgrading the proven and highly reliable Nimitz class, the Navy crammed 23 completely new, unproven technologies into a single hull. The initial budget was locked at $10.5 billion. But when these paper-perfect systems hit saltwater and real-world combat stress, they failed. Constant redesigns and heavy repairs blew the final cost up to $13.3 billion. And that figure entirely ignores the separate $4.7 billion sunk into researching its new launch system. The ultimate technical nightmare was EMALS, the Electromagnetic Aircraft Launch System. For 60 years, global aircraft carriers relied on steam catapults. Steam was reliable, but burdened with heavy moving parts and delivered a violent, sudden shock that prematurely degraded expensive fighter airframes. EMALS was billed as the permanent fix, operating on the same linear induction motor technology used in magnetic bullet trains. It generates massive electromagnetic fields for a smooth, dialed-in acceleration. The pitch was perfect. It could launch a 45,000-pound F-35C just as easily as a fragile, unmanned drone without ripping their structures apart. But the ground reality violently clashed with the Pentagon's theoretical math. When EMALS was finally installed and tested, its mean time between failures was disastrous. According to initial Department of Defense reports, the system was mathematically required to survive 4,166 launches between failures. In reality, it jammed every 181 launches, but the most fatal engineering flaw was its shared architecture. If just one of the 4 catapults went down, the crew couldn't isolate it. Repairing a single catapult required shutting down the electromagnetic grid for the entire flight deck. In a high-stakes Pacific war zone where seconds dictate survival, a single jammed system paralyzes the entire carrier. A supercarrier that can't launch jets isn't a warship. It's a 100,000-ton floating steel target for hypersonic missiles. But EMALS was only half the story. The Navy's true embarrassment, one they desperately tried to cover up, was the advanced weapons elevators. Legacy carriers relied on heavy steel cables and mechanical pulleys to haul ammunition from the deep lower decks. Fueled by overconfidence, the Navy stripped out the cables, betting entirely on electromagnetic elevators to hoist 24,000-pound weapon payloads. When the USS Ford was officially commissioned in 2017, only 2 of its 11 elevators actually worked. For years, America's most expensive warship was practically disabled, physically incapable of arming its own fighters. It took contractors until the end of 2021 to finally bring the elevators fully online. While America was trapped debugging EMALS and fixing elevators, China quietly watched the spectacle. Realizing steam catapults were obsolete, Beijing executed a massive engineering pivot. With their new Type 003 Fujian carrier, they bypassed the steam generation entirely. Scrapping the old Soviet-style ski jump ramps, China adopted EMALS directly. It was a geopolitical shockwave. How did China rapidly acquire a technology that took America 15 years to develop? While some defense experts point to industrial espionage and cyber warfare, others argue China simply fast-tracked its research by studying America's very public testing failures. The Fujian isn't just a ship, it's a direct threat to U.S. maritime dominance. But when you compare the engineering realities of these 2 oceanic giants, the strategic balance violently shifts. China successfully installed electromagnetic catapults, But they ignored one critical engineering constraint, a constraint that will become their ultimate fatal flaw in an actual battle: continuous power generation. EMALS is not a plug-and-play machine. Catapulting a fully loaded stealth fighter from 0 to 150 miles per hour in just 3 seconds triggers a massive, instantaneous drain on a ship's power grid. To solve this exact bottleneck, the USS Ford was built around 2 advanced 1B nuclear reactors. These next-generation power plants generate 250% more electrical capacity than the legacy Nimitz class. The Ford has such overwhelming output that it can simultaneously operate all 4 EMALS catapults, the weapons elevators, and its advanced radar suites without risking a grid blackout. The Fujian, on the other hand, is conventionally powered. It relies on heavy diesel generators and gas turbines, not endless nuclear fission. A conventional power plant simply cannot regenerate sustained electricity fast enough to support continuous EMALS combat launches. If the Fujian needs to rapidly launch fully loaded J-35 stealth fighters during a high-intensity South China Sea conflict, the severe electrical strain means the ship must either drastically cut its top speed or bleed power from its critical defense radars. The Ford's 1B reactors guarantee 160 to 270 uninterrupted combat sorties a day, a relentless strike rate that is physically impossible for a conventionally powered carrier to sustain. So, was the USS Gerald R. Ford truly a $13.3 billion mistake? The reality is that the Pentagon operated on extreme engineering hubris. They burned billions of taxpayer dollars testing unproven systems at sea that should have been perfected in a lab. But the final result is undeniable. America has secured the deadly combination of electromagnetic launch systems and unlimited nuclear power, a functional synergy no other nation on Earth currently possesses. China rapidly copied the hardware, but without a nuclear reactor driving the grid in an actual war zone, they simply cannot match the continuous attack rate of the US Pacific Fleet. America made historic blunders, but in the brutal calculus of maritime dominance, they still hold the high ground. If you logically believe China's rapid industrial production can eventually overwhelm America's technical superiority in a future naval war, drop your counter-argument in the comments below. For more brutal, highly researched military documentaries, subscribe to Eagle Team, hit the notification bell, and I'll see you in the next video.